We are going to start discussing our final strategy for waste management, which is landfill disposal. So we've been saying for a while that the landfill is the last resource. The cost to communities for operating and maintaining landfill sites are high, and then also there is a limited availability for lands in some cases. The remedial action is often expensive. What is the remedial action? Well, if we have pollution problems, sometimes it is very expensive to tackle these problems. And also, typing fees are increasing rapidly. So that is why landfill recycling also options are being encouraged. On the left side of the slide, I'm showing you the main problems with landfill, that environmental problems, which are soil pollution, water pollution through groundwater, the pollution of groundwater, air pollution, odor, dust, fire problems, explosions, and also in general to the natural environment. And on the right side, what I'm showing you is one example of why landfill disposal is in some cases a big problem for communities. But nowadays, landfills are operated and designed in a more sophisticated and with more a better technology, with better technologies that allow to have systems that minimize the environmental costs. This is a figure where you can see a modern landfill. The bottom liner system is designed to keep waste from coming in contact with the environment, and also particularly groundwater. They usually have cells that have specific areas where the waste is dumped, but is compacted as well, or in some cases also is even crushed. They have a stormwater drainage system where they collect the leachate, and they have this layer, this membrane to protect and to avoid the contact with the groundwater. They have also wells to monitor the groundwater quality, and also they have methane collection systems to recover the gas. They have also treatment of the leachate, or they send, in some cases, they send this leachate to wastewater treatment plants. The environmental protection in landfills occurs through a combination of four barriers: an appropriate seating, an engineer design, the exclusion of inappropriate wastes, and short and long-term monitoring. So in terms of seating of landfills, this is an important and difficult stage because in general it doesn't have it's not well accepted to have a landfill near your neighborhood. And in addition to this public acceptability, there are some other considerations, like for instance whether there is a important significant amount of rainfall during the year that can lead to higher loads of leachate, and to think about the ultimate use of the landfill, the size of the landfill, the soil type, the depth of the water table, and the wind direction as well, for mentioning some. Landfill can be seen as a biological reactor in general. So in these landfills, the transformation and the degradation of the organic matter that we have discussed before on the section of biogas production occur, and this degradation process is constant, and so then that is why it creates typical conditions on the site. The process is very slow and may still be going on as long as 25 years after the landfill closes. That is why monitoring a landfill site takes almost the same time that was operating, because the biological degradation process can still occur, and also the leaching of material of liquid from the waste can still have an effect. The liquid produced during decomposition, as well as water that seeps through the ground cover and works its way out of the refuse, is known as leachate. This liquid, though relatively small in volume, contains pollutants in high concentration. So this liquid actually is tend to concentrate metals, for instance, and other toxic compounds. But it's very interesting how the biological process combines with the chemical reactions that release, for instance, metals and dissolve metals from material that is disposed in landfills. That is why it's very important the separation of waste in order to avoid pollution problems on landfills. As we discussed before, biogas, the process of anaerobic digestion that occurs also occurs in landfills, can decrease the pH and can generate volatile fatty acids. So these acids are the ones that will allow the release of metals in the liquid, in the leachate. So the amount of leachate produced by a landfill is difficult to predict, and the only available method is water balance. The water entering a landfill must equal the water flowing out of the landfill or leachate. So using this water balance and having information about the total percolation into the topsoil layer, the precipitation runoff coefficient, and evapotranspiration, we can estimate the amount of leachate that can be produced, is likely to produce by estimating the storage. This doesn't mean that this leachate will be released. So this is the total amount of leachate that can be produced, but we don't know when the first appearance of the leachate releasing the waste material in the landfill will occur. So using this table, which of the landfills will produce less leachate? Well, this is a question that is an open question and you will have to answer. So as I said before, we know we can, through a water balance, we can predict which of the landfill sites will be more likely to produce leachate, but not when the leachate will start being released. For estimating this, we need to have information about the solid waste behavior in terms of field capacity, and this depends on its moisture content. Theoretically, the water movement through a compacted soil cell will act like water movement through a soil layer. So this can be also represented in terms of how the soil behaves. And so then we have a moment where it reaches the full capacity, and then leachate starts appearing. The time of first appearance of leachate will be influenced by the landfill's depth, and the leachate will be influenced by the landfill surface area.